Okay, so an inscribed angle is just created when, oh, that's a pretty good circle, when two chords of the circle are joined at a single point. So that is an inscribed angle. It just barely fits. That's the way I think of it. But it just barely fits. The two chords have to be connected at one single point. We also have been talking about or dealing with this type of angle. This is called a central angle. And I'm going to give two non-examples. If we have something like this, this is not inscribed. And same with something like this, not inscribed. Inscribed means it's just made by two chords, which means the vertices are on the circumference of the circle. If the vertices are not on the circumference of the circle, it's not an inscribed angle. Could be a central angle or any of those other two. But yeah, that's it for inscribed. It's very, 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 very simple. Then I want to show you something before we write down our next theorem. An inscribed angle. An inscribed angle is half. So inscribed would be something like this, is half the central angle that it connects with. If they don't connect, then we don't get this property happening. Oops. So, circle. Oh, this is a pretty good circle. I'm going to label this A, B, C. I'm going to label this D. And then I'm going to say the measure of angle ABC is 52 degrees. Find the measure of angle ADC. If we, can you see that? No?
I'll just get it off of the square changes.
Okay. So, the inscribed angle is the red angle. It's inscribed because it's on the circumference of the circle, whereas the central angle connects to the center. And we have 52 for ABC, so an inscribed angle is half of that, so you cut it in half. If you were given the inscribed angle, then you multiply by 2 to get the central angle. That's all you're doing. That's the end of the notes.